So there is a built-in function. Now you might be wondering that what is function? Right now, you can imagine a function as a black box, right? So if I say type, by the way, whatever you type over here in Jupyter Notebook and it turns green, it means that it has a predefined definition. For example, this print word, right? This print word turns into green, which means that whatever I'll mention over here in the brackets, it will be output. It will be considered as an output, right? Same goes over here. Type has some predefined definition in Python. And if I will write braces, and inside the braces, whichever variable name I'll write. So for example, if I'll write number, I'll run it. So it tells me this number variable contains an integer, right? int is a short form of integer. And if I'll do the same thing with the decimal, run it. So it says the decimal is the floating point variable, right? Now, again, let me mention, you might be wondering that this is quite a useless thing, right? This type function is quite a useless thing. Again, what are functions? We are going to learn these things in probably section 4. So you might be wondering that this type function is quite useless thing, but no, it is not. If you're working with large code bases, sometimes you don't know which data type this particular variable belongs to. So you'll have to check out the data type of a particular variable, and you can check it out by using this type operator, or not operator, but it is a function, by using type function, right? Now, let's dive into the arithmetic operators that we can work with. I'm going to create 2 new variables over here. Let's call it num1. So let's say num1 is going to be, again, 10. Num2 is going to be 20, right? So I have these 2 variables. Let me create a third one as well. Let's call it decimal1 equals to, let's say 1.5, right? Okay, so I have 3 variables now. So if I want to add up 2 numbers, right? I want to add up the values that are there in these 2 variables, num1 and num2. What can I do? Very simple. I'll write first variable name, then plus, then I'll write second variable name. Spaces are not mandatory, but you can add these spaces over here between the operator and operation, operand and operator, sorry, just for the sake of clarity. If I'll not write the spaces over here, it will not be very much clear, right? But if I add spaces, now it is quite clear. Cool. Okay. Now, if I run it, it outputs something. What is the output? How output comes over here? I'll come to it in a minute. But first of all, you might be wondering that we did not use this print statement over here, but still we got the print, right? So this is the function of Jupyter Notebook. If you're using Jupyter Notebook as an IDE, even if you're using Colab as an IDE, whatever you will write over here, if that particular statement contains an output, it will, if that particular statement is an operation, then it will output something, even without print statement. I can write it inside a print statement as well, like this. So the result is exactly same. Now, coming back like this. Okay, num1 plus num2. So how it works behind the scenes. When I say num1, when this line starts executing, it starts executing from left-hand side. So it starts executing from left to right-hand side, okay? So first of all, it checks out where is num1 inside the memory. Okay, fine. Okay, here it is. What is the value for num1? For num1, the value is 10. Okay, fine. I'm going to replace num1 with 10. Okay, cool. What else do I have? I have an arithmetic operator. Okay, fine. I'll write this arithmetic operator as it is over here. Then what do I have? I have num2. Let's go to the memory. Where is num2? Here is num2. What is your value, num2? Your value is 20. Okay, I'll replace num2 with 20 over here. Now it is a pure mathematical operation or pure mathematical expression, right? And we know that our computers are very good with mathematics. So if we run it, it outputs exactly the same result. Now you might be wondering that it should output 32 times, for 130 for this expression, another 30 for this expression. No. So the thing is, if you have multiple expressions that contain output, or if you have multiple operations in the same cell and you run that cell, then your last or latest operation gets the output. if print statement is not used. But if you want the output of both operations, then you'll have to use the print statement, right? So if I use print statement with both of them, here we go, 30 for this expression and 30 for this expression, right? So this is how behind the scenes an expression gets evaluated. All right. Okay, moving on. So this is how we can perform addition. We can also perform addition of numbers and decimals as well. So if I say num1 plus decimal 1, run it, here we go, 11.5. Why? Because num1 is 10 and decimal 1 is 1.5. So it gets 11.5. I can also say something like num1 plus num1. I can add the same number in the same number. I can get the result as well. I can also add more than two numbers as well. For example, num1 plus num2 plus decimal 1. And I can also do something like plus 3.5. Okay. Now, again, expression evaluation starts from left to right, right? So num1 gets evaluated, the 10 will be replaced over here. Num2 gets evaluated, 20 will be replaced over here. Decimal 1 gets evaluated, 1.5 gets replaced over here. And then 3.5 will be used as it is because it is not a variable, right? So it does not need any, you can say, exchange or memory operation. So if we run it, we can have a complete result, which is 35.0. Why 35.0? Since in this operation, there are a few decimal values also involved. That is why the output is in decimal value, right? So this is how we can perform addition operation. Same goes out with subtraction. We can say num2 minus num1, and we will get the result. Since num2 was 20, num1 was 10. So we got the result as 10. If I say num1 minus num2, result would be the same? Obviously not, because num1 is 10, num2 is 20, 10 minus 20 is negative 10, right? Same goes out with the, we are done with subtraction, addition, subtraction. Let's talk about multiplication. So num1 multiply by num2. So this is the multiplication symbol, right? The static mark. If I run it, so 10 multiplied by 20 is going to be 200. Then also do something like num1 multiplied by, let's say, 2.3. So here, number is going to get multiplied with a decimal value, right? We can get the result. We can also do something like number 1 multiplied by, let's say, another value like 660 or something. I mean, it works, right? So this is how multiplication works. And interestingly, if I'll add one more static over here, for example, I'll say num1 static 3, right? I will get 30 because 10 multiplied by 3 is 30. But if I add one more static, so number 1 static 3, the result is 1000 now. What do we mean by this? Actually, single static refers to multiplication and double static refers to exponential. So if I want to check out 10 raised to the power 3, then I can do something like this. I can use double static, right? So for example, 2 raised to the power 8 is going to be 256. So which means you're going to multiply 2 8 times. If you multiply by 2 itself for 8 times, you're going to get 256. So 2 raised to the power 8 is 256, and this exponential operation is denoted by double static sign. Let me add a few more cells over here. Cool, good to go. Okay, after multiplication, after we have exponential, and then let's talk about the division. So number 2 divided by number 1, we will get 2, right? Because number 2 is, guess what? 20. 20 divided by 10 is 2. You can also do something like 8 divided by 4. We'll get again 2. We can do something like 60 divided by 10, 6, right? So the result of division operation is always going to be in decimal point, right? Why? Because if I do something like 8 divided by 3, I'll get 2.6666, right? Cool. Now, after division, by the way, all of these operations are going to get used later on and when we are going to build any, high-level program. So let's just get our basics right over here. And then almost our last operation is going to be modulus operator. But before modulus operator, let me tell you, if you want to skip these values in decimal in division operator, which means if you want to get the result of division operator in integer, not decimal, what you can do is you can say 8 double divided by 3. It will skip all the values that are after decimal point. And finally, we have modulus operator. So if I say 8 modulus 3, run it, it gets me 2. How? Let me go over here. Okay, so we have an example over here. So if I divided 20 by 6, right? The division answer is 3 because 6 into 3 is 18, right? And then whatever value is left after subtracting 18 from 20 is actually called remainder or the answer of modulus, right? So the same result over here. So if I do something like 20 modulus over that 6, so I get 2 over here. And if I say 20 divided by 6, I get 3 over here, right? Or if I say double divided by 6, then I'll get 3 over here. So if you want to get the result of division, this upper result, then we would use slash mark or double slash mark. But if we want to get remainder or modulus, then we would use this percentage mark. So I think that's about it about arithmetic operators that we can use with numbers or decimals. I'm going to leave you with a question. Okay, so here is an expression. 10 divided by 5 multiplied by 3 plus 1, let's say multiplied by 2 minus 3. Okay, so I've randomly written an expression over here. I want you guys to evaluate this expression without running the Python code and see before running the Python code what was your answer, and then run this line and see if your answer matches the Python code as well, and then try to find the logic behind it and see if you can find the logic or not. I can give you oh, accidentally I ran it, so let's assume that you have not seen that. Okay, so let me write the mass over here. That this word you might have learned in the basic classes. D stands for division, M stands for multiplication, A stands for addition, and then subtraction. What do we mean by the mass? How it works? How the result of this expression is 5. I'm sure if you will evaluate it without the mass rule, the answer is going to be different. So let's see what is the mass rule and how it works.